Okay, girls, now I'm going to talk about bond length and this thing called lone pairs, as well as bonding electrons. So this is just going to finish off our little bit on single bonds, and then we'll have another video about double bonds, but that'll probably do you for this section. So bond length. So now we're on page 3 of the notes still. About 2/3 of the way down the page, there's a title that's called bond length, or almost the bottom quarter of the page, and it says, in a molecule, the like-charged electrons will repel each other as well as the like-charged nuclei. So the interplay between the attraction and repulsion determines the final distance between them, and we call this length the bond length. Okay, it's not a very big gap there, but we call this the bond length. Bond length is defined as the distance between a pair of nuclei. Can you have a look on this picture here? That bond length is going to be the distance between the nuclei, okay, that are sharing a set of electrons. So you can see here that they're sharing electrons, and the distance between those two is called the bond length, and that is something that is measurable. Okay, so below that, we've got some more questions showing you some of those electron dot diagrams, and what I'm going to introduce 2 new terms to you. What are bonding electrons and what are non-bonding electrons, or what we call lone pairs. So to begin with, we're going to count the number of electrons in the outer shell of chlorine. Now you might want to pause. You can probably do this all on your own. And we've got the number of electrons in the outer shell of chlorine. Welcome back. So the number of electrons, we had 1, 2, 3, 4, 5, 6, 7. So we have 7 electrons in the outer shell of chlorine. How many in the outer shell of hydrogen? We have 1. How many bonds, therefore, or how many extra electrons does chlorine need? It needs 1. How many bonds or extra electrons does hydrogen need? It needs 1. When you bond them together, do all electrons have an full outer shell? This is what we did before. 1, 2, 3, 4, 5, 6, 7, 8 for chlorine. So chlorine is a yes. And hydrogen, it has 1, 2. So chlorine is a yes. And so our answer to that one is going to be yes. Okay, so let's do one more of these booklet questions so that we make sure we're there. So give it a pause and see how you go, and let's come back in. All right, so how many outer shell electrons are there in the oxygen? Let's count them. 1, 2, 3, 4, 5, 6. So we should end up with 6. How many in the outer shell of hydrogen? There should be 1. So how many bonds does oxygen need? It's going to need 2. How many bonds does hydrogen need? It's going to need 1. So that means that each hydrogen can occupy one of those bonds or fill the bond for the oxygen, and you end up with full outer shells. Yay! I'm going to get rid of my hat. So let's just finish off these notes here. It says that water contains how many atoms? So it contains 3 atoms, we can see, 1, 2, 3, hence being called a polyatomic molecule. Okay, you could say triatomic, but we don't really. We just say that diatomic if it's got 2 atoms in it, and anything more can be a polyatomic molecule. Remember when we learned about polyatomic ions? This is the same thing. Okay, so that's more than 1 molecule, but in this case, we're going to say more than 2. Electrons being shared from different places. So what we have here is the bonding electrons, is that next bold bit there. So these are the electrons that are being shared. All right, so our bonding electrons, I'm just going to clear my pen markings. My bonding electrons are these ones in yellow. So they would be the bonding electrons. Now there is a word for the non-bonding electrons. So the non-bonding electrons are these ones in green. Okay, these are called non-bonding electrons. they exist in pairs, so they are called lone pairs. All right, so these are the electrons that are not being shared between the atoms. The lone pairs do not hold the molecule together, but they do play a role. Yeah, and that role is going to come into play when we talk about the shapes of different molecules. So these play a role in the shape of the molecule. Okay, let's have one last little look at the rest of our notes here. So you can see here is a picture of fluorine. You can see that you've got lone pairs out here. And you can show a single bond, yeah, by just doing one line. So the bonding pair here, this is a single bond. What it actually is showing me is 2 electrons. Yeah, 1 electron from this fluorine molecule, 1 electron from this fluorine molecule, and they're sharing both of them. So that's a bonding pair. So 1 pair, so that is 2 electrons. 1 pair of shared bonding electrons is called a single bond. Okay, so that's that very last line on this page. We can ignore all the inner shell electrons. We're only going to focus on the outer shell electrons. So although we drew them before, you don't need to draw them. Yeah, you can just draw your valence electrons. It's going to take up way less space. The benefit to drawing them is that you get to see the difference in size between your 2 molecules. It's pretty hard to squish chlorine down to the size of hydrogen. So that's why you end up with something that looks like this. You can see how chlorine is so much bigger than hydrogen. Okay, so the inner shell electrons don't play a part, so therefore we just leave them off diagrams. And that is the end of single bonding.